Hello everyone and welcome. In this EPIC GitHub tutorial, we're going to learn about Git, GitHub, why they are important, how you can use them to make it easy to work in groups and collaborate in code development. We will also be looking into how to contribute to UFS and EPIC repositories. As a brief introduction, my name is Natalie Perlin, and I'm a senior systems engineer currently working on NOAA EPIC project. Tutorial materials and a training session could also be accessed at the NOAA EPIC location on GitHub under the training GitHub repository. The tutorial presents the general directions that are mostly for Mac and Linux system and using the terminal application. Windows have it slightly differently. And it also assumes that the users complete all the prerequisite steps as listed in a README file at this training GitHub repository, which include that you have a Git installed, either using Homebrew for macOS. For Windows, it will be Git Bash. You are also familiar with basic command line interface or CLI commands, and you also open a GitHub account. The outline of the tutorial will be as following. Part 1 will cover the Git and GitHub basics. We'll talk about the Git and GitHub terms and concepts. We will cover some of the basic Git commands to get you up. We'll set up a SSH key pair to make it easy GitHub authentication. We'll create our own repository, track your local changes, and then push these local changes to GitHub repository. Part 2 of the tutorial will be more on working with remote repositories. We'll be talking about GitHub branches, pull requests, issues, and discussions. We'll be checking out remote repositories. We'll be fetching and merging remote branches. We'll be creating and managing forks, submitting pull requests, keeping local repositories in sync with remote ones, and something that is related to pull requests, we'll be talking how to resolve conflicts. So part 1, basic Git terms and concepts. So Git is a free and open source version control system, which is basically a program. And the version control system is a software that provides management of changes that you do to computer programs or documentation, websites, etc. GitHub, on the other hand, is not a program. It is a host website for many free and open source repositories, including those by NOAA. And GitHub interacts, you can interact with GitHub using a Git, either a command line interface or the GUI Git system. However, we'll be using exclusively the command line interface in order to better understand the main concepts. After knowing the command line interface, you can easily switch to the GUI version. The next term is repository, or short repo for short, is a set of code, documents, or websites that are version controlled by Git. Branch is a working version of a repository with its own change history. So you may have several branches in your repository. So think about it as like parallel universes. And you can switch from one branch to the other and doing your own changes and testing either the concepts to solve the problems in the code or having specific features of each branch. And you can work with each branch independently. So now we'll look into basic Git commands for the local Git commands. So git config will help you to configure your Git experience, your username, your email that could be attached to the commits that you do, and then or will go into records of the repository, could be seen on GitHub as well if you contribute to somebody else's repository. The next is git init, where you create your local repository in the present directory that start to be being tracked by Git. Then git add, you will add files to be tracked by Git. Git commit is the way you save changes that you made to repository, and you may specify what type of changes have you done. Branch is, again, the command can let you know what current branch are you working on, and it also can copy the current branch and create a new one. Using git checkout, you can check out a specific branch within the repository. That means you switch from one branch to the other one. Some of the options with git checkout allows you also to create a new branch. Git log will show you recorded or committed change history for the repository. Git status, on the other hand, will show you changes to the repository since the recent commit. So the changes that are not committed yet. A git diff will show you the local changes file by file, line by line to the repository since the recent commit. So here is something that we'll be using terminal for. We're going to follow along and use it on terminal and issue the same commands to have a similar experience. So in my case, I have already some configuration set up. So if I issue git config -- global user.name, it will show me that I'm registered as Natalie Perlin. I can also change it or set it differently if I want to by adding the name to the same command. So adding my name in quotes after using .name. I can also add my email, git config -- global user.email, give my email, and when I issue it next time, it will know my email that will be globally tracked for my local username. Then you can also specify a basic editor or core editor that we may need later for example, adding commits or resolving conflicts. And in my case, it was not set up. So I issue git config -- global core.editor and give the editor my preference. When I next time query it, it will show me that I have Vim set up as an editor. All these configurations are stored in your .git config file under your home directory. So you can view it either cat or using your core editor or editor of your choice. And this is all of the configuration that we have set up, user and core. So by git init, our newly created local repository starts to be tracked by Git. So in the terminal, what I do, I create a new directory, my local repo, I change directory to the new one, and I issue git init command. And the prompt says, you may not get this prompt, but in my case, it informs me that master will be a name of the initial branch, and you can change it. So in this case, after issuing the git init command, you will have the new directory created under your main directory called .git, where all of the changes to the repositories are recorded. So in this case, I'm making sure that, yes, this directory is present by issuing ls-d is for directory and git.git. And here it shows that, yes, this is .git directory. Dot means this is hidden. If you issue simple ls command, it will not be shown. Then git adds a new file to the ones to be tracked by Git. So I can create a new simple README file by using just echo command and say, okay, this is my new repository, and record this string into README file. Then make sure it's recorded and issue git add README file. So README files start to be tracked by Git. But this is not all. We also would need to say that what kind of changes have been made to the repo. Git add simply adds to the list of files that are trackable by Git. So git commit -m is for message. It adds a message. In this case, I say, okay, it's first commit to my new repository. And this is added as a message to my new commit. Here is the concept of git branch that we'll be testing. When we just issue git branch, it will show us the current working copies and other copies that we recently work with. Right now we have only master branch, and the working branch will be marked by the asterisk in front of the name. Then in this case we have only master branch initially. Then we can create a new branch by issuing git branch new branch, and then git checkout, and switching to this new branch. Git checkout new branch will make our working location in the new branch, not in master. Here is the next thing, git log. It will show a recorded or committed change history. So here's an example. We switch to a new branch and we will want to add a new file. So we're using touch command, touch a new file, txt. We add some text to this file. We'll add it to be tracked by Git. And here our ls shows that we have two trackable files. Then we issue another git commit where we say we'll be adding a new file. And when we issue git log, it will show us two commits. First will be most recent one was adding a new file, and the previous was the first commit to a new repository. The git status would show us the changes to the repository and to the branch we're currently located since the most recent commit. So here is, for example, git status. If we are on the new branch, we haven't done anything, so there is nothing to be committed. And if we decided to add, we decided to add another line to README file, and then we issue git status, it will show us that we are in a new branch and we have some changes that have not been tracked yet. We need to use git add and git commit in order to record the changes. There is another way, more detailed, of looking at the differences. Git diff would show us local changes to the repository file by file, line by line, since the most recent commit. So we are in the new branch. and if we issue git diff, it will show us that the change was done to the README file since the most recent commit. The minus will means that lines have been subtracted or removed from the file, and the plus means that they have been added. In this case, it will show that the line was added to the README file. We can also ask the difference, what were the differences since the last commit between the current branch and the master branch. It will say git diff master, give the name of the branch that we want to compare it to, and then it will show that the differences were first in the README file where the line has been added, but we also has a new file that has been added to since the last commit. So in one case, we just don't have, in the master, we do not have this file present. In the new branch, we do have the new file present. It's sometimes very handy to compare the changes that have been done since the last commit to a specific file. Then we will issue git diff master dash and the name of the file. If you have a directory structure, that will be a directory structure starting from the top one. So dash means that the arguments that will follow after dashes refer to the name of the file and not any keywords. So then we'll see the differences that have been made only to the README file. So let's navigate to a dashboard and to set up our profile and then our new GitHub repository. So we'll navigate to github.com dashboard. It will take you to your default profile. So in my case, it's Natalie Perlin, and you have the user picture that you can, it provides some defaults, but you can also add your own. So what you can do, you can click on your user picture, then you choose settings from the menu that opens drop-down menu, and then you choose public profile, and then you can populate it with the information that may be helpful for your peers, for the developers that you work with. Okay, next, in order to facilitate the communication between your local computer and GitHub and to enable passwordless connection, it's very handy to generate SSH key pair and upload it to a GitHub account. So from settings, on your left menu, you choose, you click on SSH keys and GPG keys. Sometimes you need to scroll down on the left menu. Then choose a new key. Then if you switch back to local terminals, we would need to generate new key pair. The new key pair will consist of a public key and the private key. And this is done using SSH key gen command with -t option gives you, or you set the type of the key, and -b is the strength of the key in bytes. So SSH-keygen -t RSA -b 4096 will create as a key pair. You will be asked to give your own name, or you can choose a default name. If you just hit enter, you may not need to enter any passphrase for now, so just hit enter twice. You can change it if you want it later. It's not needed for our current test. Then we can copy our public key that will have a .pub extension. So private key will be ID_RSH, or the name of your choice, and the public key will have the same name plus .pub. So we copy it. We can just copy it into using the mouse, and then paste the output of your cat command into your key portion on the GitHub page. Then give it a title and click SSH key. That's almost all. One more thing that you may need to do, for example, on Mac OS, you may need to add your private key to the SSH agent. You can start the new SSH agent by issuing this command, eval quote $, then SSH agent -s in the parentheses and close quote. Then the next command will add your key to the SSH agent using SSH-add and then name of your key. Prior to Monterey, you may have used, you may need to use SSH-add -k command. But in this case, in the newer systems, you don't need to do that. So after you've added your key, private key, your pushes or uploads to your GitHub repositories will not require password. And you can get some more help on setting up SSH keys on SSH.com Academy, or on some GitHub pages, GitHub help pages. Okay, let's create our new repository on GitHub. So we would head to github.com/new, and then it will take us to a new page where we can create a new repository, give you name of the new repository. The GitHub would automatically check if this name was available and let you know. If it's not available, in my case, it says my new repo is available. This is the name I'm giving it to, the same as the one that we created in locally in the terminal. And then we can add a description, but this is optional. Another thing that since we will be uploading or pushing a repository from the terminal, from the local one, we may not select add a README file. We'll add it from pushing from the local repository. And then we can scroll down on the page and click on Create Repository. So now we'll be pushing our local repository to GitHub, and we will need to learn a couple of new commands. It's git push that will upload our local repository contact with the committed changes to a remote repository that has been synced with the local one, or rather local one is synced with the remote one. And git remote will let us manage a list of remote entries that are tracked by local repositories. Remote-v will query remote repositories or repositories that are tracked, and will show us the type of the repositories or the addresses. Remote at origin, and then we provide the address, GitHub address of the repository, whereas origin refers to a default remote repository name. You can name it differently. You can give a more meaningful name to your repository. Then we can return to our terminal. After that, we return to our terminal and navigate back to our new repository. Here we are in the repository directory. So initially, when we issue git remote, it shows us nothing. There is no remote repo connected to our local one. And when we issue command git remote add origin and give the address, which will be in the form of git@github.com column and your username / the name of the repository. Then it will add this repository to your local one to sync with. So when next time we issue git remote -v, it will say that we have origin, which is default name for the remote repo. The address is for fetch, and origin, the same is for push. The next, and when we can check which branch are we in, we issue command git branch. It shows that we are in a new branch. Next, we'll push both branches to GitHub. So when we issue, when we want to push all of them, you can specify one by one. For example, git push origin master. Even though we're new branch, it will push the master branch into the remote repository. And when we issue the git push origin new branch, it will upload our new branch into the origin repository and create a new branch there. And that's it. We're done. We have a new repo. And here is the information about the branches that have been created. The new branch, local new branch is master remote, will be tracking master. Master local will be tracking master remote, and the new branch local will be tracking new branch remote. So we can go to GitHub and check it out. So next part 2, will be on working with remote repositories. We'll check out remote repositories, work with forks and clones. We'll deal with GitHub branches, pull requests, issues, and discussions. We'll be fetching and merging remote branches. We'll be creating and managing forks, submitting pull requests, and keeping local repositories in sync with the remote ones. So let's navigate GitHub repositories. Any public GitHub repositories can be forked or cloned. These are similar terms, and we'll talk about the differences. So fork is a completely independent copy of some remote Git repository that you can use to track your local ones, either after target original repository or sync with your fork. Whereas the clone is a linked copy, usually local copy, that is synchronized with the target, with the remote repository. So next we can navigate, for example, to our NOAA EPIC training GitHub repository. We can navigate it to by using the code repo, pushing the code button. Also, we could look at a more populated and more active UFS community, UFS weather app repository that has currently populated with issues that are being solved, pull requests, and also have discussions. You can look through issues and pull requests and look into the discussions and reply to a thread or you can comment on issues or pull requests. Next, you can create your own fork of the repositories. So you would go to, you'll create your own fork by navigating to main page and clicking code. Then in the right top corner, you have fork. And when you enter click fork, it will have a small menu, and you say create a new fork. Next, we'll keep the repository name similar to the original one and keep the same description. And then we click create fork. And here we have, voila, we have the training GitHub, local to my account, and it specifically says that it's forked from NOAA EPIC training GitHub.